All right, so we're continuing our journey towards a better understanding of the base 12 version of pi by creating a diagram that generates all 360 degrees using base 12 geometry. So in this video, we are progressing from the first to the second ring, and I just wanted to go over this little paragraph of information that I've created underneath each ring of the diagram. So you can see I first give you the radius of the circle that we're working with. So here it's 3.2 root 2. Then I convert that to its square root version, which here is the square root of 18.08. And then I'm giving you its coordinates for where it crosses the x-axis, just so we have that information as well. Then we're adding to that 0.5 root 2, which when you convert to a square root version is the square root of 0.42. So then we get the radius of the second ring of the circle, and then I give you that x coordinate as well. And then I'm subtracting the smaller number from the larger number just to see the gap between the two circles on the x-axis. And then here you can see I'm doing the same thing for the next ring of the diagram. And so just to be clear, the scale of the diagram that I'm drawing, I'm still using graph paper for all of the measurements. So that means that when you see like 0.1 is like 1 square of the graph paper, and so 0.06 is, or 0.56 is like just less than half of one of these squares. 0.029 is just less than 1/4 of one of these squares. So just to give you an idea of the scale of the entire diagram and the relationship of all these lines and circles to each other. So another aspect of the diagram as we progress from ring to ring are the angles, or the sections of degrees that we're creating within each ring. So the first ring was generating sections of degrees at 7.6 degrees, and we get that number by dividing 26 by 4. So we're generating, again, a circle of 7.6 degree sections. So the second ring, we're going to be dividing 26 by 8, because that 4 and that 8 comes from the division of the inside of one of these rings. You have these two smaller circles inside these larger circles, and then we get the halfway point and the quarter point. So that's how that works. So in the second ring, again, we're dividing that circle into sections of 3.9 degrees. And then the last bit of information I want to go over is the actual angle inside the smaller circles. So again, the first ring, it was 119 degrees in base 12. So for the second ring, we do the same calculation, the n minus 2 times 130 for base 12 divided by n. N is the number of sides in the polygon. And so we get this second value here for the degrees, the angle inside the small circle. So I think that's enough information for this video. Again, we're just progressing from ring to ring. In the next video, we're going to go to the next ring and carry on with